look at the gas laws, and we're going to put them all together. And typically when you see these put all together, you're going to have to determine what gas law you need to use in order to do the problem. So I've got three examples. Obviously, they're going to use Boyle, Charles, and Gay-Lussac's law because that is all that we have learned so far. Just to kind of recap where we were, Boyle's law was pressure 1 times volume 1 is equal to pressure 2 times volume 2. Charles' law is volume 1 over temperature 1 is equal to volume 2 over temperature 2. And then you have Gay-Lussac's law, which is pressure 1 over pressure 2. So your initial pressure and temperature is equal to your new pressure divided by your new temperature. Also, just to recap, you do have to make sure that you have the correct units. Anytime you have a pressure, you have to make sure that you are using ATM, atmospheres. So if you don't have atmospheres, we're going to convert it out, so we do. Anytime we have a volume, you have to use liters. If you don't have liters, you're going to convert it out, so you do. And then finally, with your temperature, anytime you have a temperature, you have to use Kelvin. So if you don't have Kelvin, you're going to convert it out, so that way you do. So looking at these three equations here versus the problem that's given, it says a gas occupies 900 milliliters. Milliliters is a type of volume at a temperature of 27 degrees Celsius. What is the volume? So we have volume at 132 degrees Celsius. So this math problem has temperature and volume. So because this math problem has temperature and volume, I'm going to use V1 over T1 is equal to V2 over T2. I'm going to use Charles' law. My volume here, the 900 milliliters, is at a temperature of 27, so I'm going to call those my ones, V1 and T1. My new volume I'm solving for, and then there's my T2. So when I look at this, I need to make sure that I have the correct units. Volume always has to be in liters. Temperature always has to be in Kelvin. So I need to convert my units out so I have the correct units. So the milliliters going to liters, you divide by 1,000, or you move your decimal place 1, 2, 3 times. Before the conversion, we had 1, 2, 3, 4 sig figs, which means that I need 4 sig figs after. So we're going to convert that to liters. The Celsius needs to go to Kelvin. In order to go from Celsius to Kelvin, we're going to add 273. So 27 plus 273. That's going to give me 300 Kelvin. I'm going to drop a decimal place at the end of that because it is a whole number, and we need to rescue out those sig figs. My 132, we're going to add 273 to that as well, and I got 405 Kelvin. So now that I've done all of my conversions, I'm going to use Charles' law to do the math problem. We have 0.9000 divided by 300 is equal to V2. I don't know that, so I'm going to solve for that, divided by 405. To get V2 all by itself, we have to cross multiply. To get V2 all by itself, then we're going to divide both sides by 300. So now I just pick up my calculator. We have 0.9 times 405 divided by 300. This number is 4 sig figs, 3 sig figs, 3 sig figs. So my answer is going to have 3 sig figs. So 1.22, I'm solving for volume, so that is liters. So I showed my work. Correct answer, correct number of sig figs, and then the correct unit for my 4 points. Sorry, I didn't realize that cut off. So that is my 1.22 liters. Now the next math problem that we see in the examples here, it says a gas has a pressure of 699 millimeters of mercury at 40 degrees Celsius. So that's pressure and temperature. What is the temperature at standard pressure? So we need to remember something else on this one. We have STP, standard temperature and standard pressure. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atm. This is also on your reference sheets. If you need that information, it is also in your notes. So when it says that we're at standard pressure, we're at 1 atm. So we used STP there. I don't care about the temperature because temperature is going to be held constant because we have pressure versus temperature, so we're going to use Gay-Lussac's law. I again need to check my units to make sure that I have the correct units for everything. Millimeters of mercury needs to go to ATM. So we have 699 millimeters of mercury. To get that into ATM, we're going to use the 760 mmHg is equal to 1 ATM. Before the conversion, this had 4 sig figs, so when I convert it out, I need 4 sig figs again. So you get 0.9197 for my 4 sig figs in ATM, atmospheres is the unit that we have to use. 40 degrees Celsius, so 273 plus 40 is 313 Kelvin. And then this is already an ATM, so I'm good to go there. So now that I have all the different units, these are my ones because they're attached together. The new temperature is T2, this is P2. So now I'm going to plug it all in. 0.9197 divided by 313 is equal to 1 ATM times T2, divided by T2. To get the T2 all by itself, we're going to have to start by cross multiplying. 0.9197 times T2 is equal to 313 times 1, which is just 313. To get T2 all by itself, we have to divide by 0.9197. So I am going to take 313 times 1, which is just 313, divided by 0.9197. This number has 3 sig figs, 3 sig figs, 4 sig figs, so when I get my calculator answer, I need to round this to have 3 sig figs. So T2 is 340 with a decimal place that gives me the 3 sig figs that I need in Kelvin. And we have one final practice problem here. For my last practice problem, it says a gas occupies 12.3 liters, that's a volume, at a pressure of 40 millimeters of mercury. Pressure. What is the volume when the pressure increases to 60? So in this problem, I just have volume and I have pressure. It doesn't mention anything about temperature. So if I just have volume and pressure, this example is going to use Boyle's law. For Boyle's law, I have to have atmospheres and I have to have liters. This is in liters, so I'm good to go there. The pressure is in millimeters of mercury. So I'm going to take 40 mmHg. We're going to do this conversion. It says 1 atmosphere is equal to 760 mmHg. That converts the units. So we have 40 divided by 760. So when I do this conversion, the 40 with 3 sig figs goes to 0.0526 mmHg. On the second conversion, it's going to look identical to this setup, except here I'm going to use 60. I'm just going to use that same work. 60 divided by 760 with 3 sig figs is 0.0789 ATM. So I have all the correct units. Once I have all the correct units and I know which equation to use, I'm going to just plug in my numbers. P1 times V1 is equal to P2 times V2. So my ones are attached together first. So P1, 0.0526 times V1, 12.3, is equal to V2, I don't know that one, times P2, 0.0789. To get the volume all by itself, we're going to divide both sides by 0.0789. So now I just need to get my calculator and multiply these two divided by 0.0789. 0.0526 times 12.3 divided by 0.0789. This number, the way that it's written, only has 2 sig figs. This number is 3, 3, and 3. I have to write my answer with 3 sig figs. So to get 3 sig figs out of that number, when my calculator just says 8.2, I'm going to put a 0 on the end, and that gives me the 3 sig figs that are needed. The unit that I need is for volume is liters, so I'm going to put an L at the end of that. So as you're going through, identify what units are mentioned in the equation, figure out which of those units are changing, and then you'll be able to figure out which gas law to use from there. If you guys have any questions, make sure that you ask. Otherwise, have a great day.